Okay, last time we discussed about the graphical representation and the concept of non-ohmic conductor. And the first non-ohmic conductor is filament lamp. And there are some other non-ohmic conductor also in our syllabus. And we only discussed one last time, that is filament lamp. And the second non-ohmic conductor is thermistor. Thermistor is also it is also based upon the temperature concept. Number two, thermistor. So, thermistor also depends upon the temperature, but there is only one difference. In filament lamp, temperature is directly proportional to resistance. In filament lamp, temperature increases, resistance increases. So, thermistor is opposite of filament lamp. When temperature increases, resistance decreases. So, thermistor is the opposite of filament lamp. When temperature increases, resistance decreases. So, this thermistor is the opposite of filament lamp. And if we consider the graphical representation, so there are two types of graphical representation. First one is between resistance and temperature. And the second graphical representation is between voltage and electric current. Resistance, temperature, current, voltage. So, as we already observed that temperature and resistance are inversely proportional, so there will be this type of graphical representation between temperature and resistance, because when temperature increases, resistance decreases. So there will be a curved line like this. And if we talk about current and voltage graph, so if temperature increases, resistance decreases. And at low resistance, there will be high value of electric current. So it means graph bend towards the current axis like this. So this time, when temperature increases, resistance decreases. In filament, when temperature increases, resistance also increases and current decreases. So this time we have opposite of the filament. And this is the concept of thermistor. Thermistor is basically a temperature dependent resistor. And the symbol of thermistor is, this is the symbol of thermistor. So we need to draw resistor and we need to mark this line. So this is the symbol of thermistor. So in circuit, if you need to identify the thermistor, so this is the symbol. And if they ask you to draw thermistor sign, So this is the symbol or sign for thermistor in the circuit. Then we have the third non-ohmic conductor, in which current and voltage are not directly proportional to each other. LDR. LDR means light dependent resistor. Light dependent resistor, and light dependent resistor will be, again we have to draw a resistor sign. For light, we have to add two light rays in this way. So this is the symbol for, or this is the electrical symbol for LDR that we have to draw in the circuit. And just like the thermistor, it is also inversely proportional, but factors are different. In LDR, when light intensity, so when light intensity increases, resistance decreases. So this is also inversely proportional. And we use this setup in automatic street lights. For example, if we consider this application in automatic street lights, so what happens in daytime? In daytime, we have high intensity of light because sun light is available. So there is high intensity of light. And because of that high intensity, so intensity is high, resistance will be low, voltage also low, because resistance and potential difference or voltage are directly proportional. So when resistance is low, potential difference will be also low. And lamp, if we talk about the lamp or the street light, that will remain off because we are not getting the suitable voltage for the lamp. So that's why it will remain turn off. But in the opposite scenario, if we consider the night time, so the surrounding intensity of light is now low because sunlight is not available, so the intensity as compared to the daytime decreases and resistance increases. Voltage also increases, so lamp will turn on because lamp will get suitable amount of voltage and it will starts to glow. So in this way, we can use LDR in automatic street lights, right? So this is another type of non-ohmic conductor because voltage and current are not directly proportional. They are inversely proportional or like different link with each other. And the last non-ohmic conductor is diode. Okay, diode is a component basically which allows to flow current in only one direction. So it allows current to flow in one direction only. And the symbol for diode is like this. So this is the symbol for diode. And let's suppose if we want to prove this concept of moving current in one direction only, so let's suppose we have two different types of circuits. In the first one, diode is connected with the battery, and on the other side, we have a lamp. So this is one representation of the circuit. In the same way, again we consider diode, and this is the lamp. So in both circuits, there is only one difference. In the first circuit, you can see positive end is connected with the positive terminal of the diode, and the negative end is connected with the negative terminal. But in the second circuit, positive terminal of diode is connected with the negative end of the battery, and negative end of the diode connected with the positive end of the battery. So this is the difference. So in the first circuit, when current or the charges starts to flow from positive side, so positive, they are same terminals. So it allow the current to flow from positive to negative direction. So in the first circuit, electric current can easily flow. And this flow of current is called forward biased. Biased means it allow the current to flow in forward direction. Second, we have reverse bias. Because positive is not connected with positive, so it will not allow the current to flow from positive to negative direction. Because when it starts to flow, there will be a negative terminal of the diode and it will not allow the current to flow from the opposite side. So this is the problem with diode. So that's why it allow current only in one direction. So that's why we have to connect positive with positive terminal and negative with negative terminal.
So you can only use this in series circuit, right?
Yes. Basically, if we use in parallel combination, so still we have to consider their individual path, right? If there are three diodes, let's suppose connected in parallel combination, so we consider their individual directions and then we define what will happen in the circuit. We have one question also. after this, we will discuss that question in the theory paper related to the diode. So it will clear your concepts also. So basically, in reverse bias, you can simply say there will be no current. Or in another words, we can say we have infinite resistance. Diode have infinite resistance. Infinite resistance means your circuit is not completed, so you don't know about the exact value of resistance. So that's why we call it infinite resistance, right? Because charges are not moving from positive to negative terminal. So that's why we consider this one as infinite resistance. And let's suppose if we consider questions from these non-ohmic conductors from the past paper. So let's see what type of question we have to solve in the past papers related to these non-ohmic conductors. Because for ohmic conductor, we have very simple formula V is equals to IR. And we used to solve questions with V is equals to IR formula easily. But for non-ohmic, we have to check which component is connected in the circuit, and each component have its own property. So it depends. Okay, so this is the question. Now you can see both diodes are in parallel combination. Last time we discussed the first part that is related to the filament. We need to copy paste the idea from the filament lamp. Now the second part is very important. We have to calculate the reading on the voltmeter. Question is simple, but we have to figure out the circuit, how circuit works. Then we have to find out the value of voltmeter with the help of the orientation of the circuit. So first of all, in circuit, you can see there are two different sources. One source is 12 volt and the other source is 3 volt. And 12 volt flows current from left hand side, and this 3 volt starts to flow charges from right hand side. So both are opposite to each other. So this is the difference. And secondly, if we draw the current path from 12 volt side, so current starts to flow in this direction. And from the first diode that is connected with 4.2 ohm resistor, current can easily flow, right? Because it is connected with positive terminal. But the problem is when this current flows from this diode, the second diode, so it got blocked, right? Because this is oppositely connected. Got it? Any confusion?
No.
In the same way, if you consider the 3 volt, so 3 volt also starts in the same way. It reaches this point, but again the problem is when it tries to flow from this direction, so again it got blocked because of opposite connection. But from the other side, it can easily flow. So basically, if we talk about voltmeter, so voltmeter records the voltage of both combinations. So basically, from left side we are taking 12 volt, and from right side we are taking 3 volt. and one diode allows the current from 12-volt side and one diode allows the current from 3-volt side. So when we find out the reading from the voltmeter, so we observe that one time there is only one value of voltage is allowed. So the voltage will be equals to 12 minus 3, because 12 is moving from one side, 3 is moving from the other side. So just like the combination of the cells, they are opposite to each other. Yes. So it will be equals to
It's for
9
2
volt.
marks.
Yes. Basically, it is for 2 marks, but you just simply need to show that both are in opposite direction. So we need to subtract them. And 1 mark for writing correct answer. Okay.
Can we do a few more of these type of questions?
We have other parts of this question also. We have to find out the current in the other resistor reading on ammeter. So we still have parts of this question. Now this is related to first part is only for the voltmeter. Now second part is only the current in 4.2 ohm resistor. So 4.2 ohm resistor means this one. And from 4.2 ohm resistor, 12 volt can easily pass through the 4.2 ohm resistor, but when it passes through 4.2, it faces 3 volt, which is moving in opposite direction. So again, they follow the opposition. And that's why if we find out the current for 4.2 ohm resistor, so I is equals to V over R. And again, the same problem, 12 volt is moving from positive to negative, but we are also following the opposite voltage divided by resistance, right? Because the problem is when this blue line charges is for the 12 volt. So when it passes through 4.2, so it faces the purple line in opposite direction, right? So this is the difference. And the final answer, 9 divided by 4.2, 2.14 ampere. Now next part is very important. It will also clear your concept related to the direction also. We have to find out the current in the second resistor. So what do you think about the second resistor?
It's only 3 volts.
Okay. Okay. Now, just like the first part, 12 minus 3, the same resistor also follows the same pattern, but the problem is one. Basically, 3 volt is smaller than 12, right? So it cannot overcome 12 volt. 12 volt is greater than 3. That's why 12 minus 3 gives you 9 resultant voltage. But 3 is smaller than 12. So 3 minus 12 means minus 9 volt. It means there is deficiency of 9 volt. So the charges or the potential difference of 12 volt is greater than 3 volt. So 12 volt will not allow the charge flow from the 3 volt from positive to negative direction, right? So that's why there will be zero current, because 3 volt is less than 12 volt. And let's suppose if you find out the value of electric current, so it will be like 3 minus 12, like this. So this is not possible, right? Because you will get negative value. So that negative value is current is not possible, because answer is very simple. 3 volt is smaller than 12. So the charges of 3 volt and the work done by the 3 volt battery will not overcome the work done by the 12 volt battery. Right? For example, if one car is moving with 3 Newton force and the other car is moving with 12 Newton force, so definitely 12 Newton force car overcome the speed of or the force of 3 Newton car, right? But 3 Newton car cannot overcome the force of 12 Newton car, right? So the push of the charges for 12 volt is always greater than 3 volt. So 3 volt cannot overcome 12. So this is the problem. So that's why the value of current will be 0. Okay.
Okay.
And for ammeter, we know that we have parallel combination. So in parallel combination, we have to combine electric current. So we know that one value is 0, other value is 2.14. So final answer remains the same. So basically, in this question, there is more concepts as compared to the calculations. And last time, I think we discussed the formula for electrical power and energy also. Yes. So the last part is calculate electrical power transferred in the 4.2 ohm resistor. So there are three possible equations for power. P is equals to VI, P is equals to I square R, P is equals to V square R over R. So it's your choice. You can use any one of your choice. Let's suppose P equals to VI. So voltage is 9, 12 minus 3, and the current value is 2.14. And for example, if you want, you can also use P is equals to I square R. And for example, if someone use the third formula, so this is the third possibility. So from the first formula, let's suppose if you multiply 9 by 2.14, it will be 19.26. And for the second part, you will get 19.23. So it means you will get round of 19 watt power. So you can use any one formula of your choice. You will get round of same answer, right? From all these three equations. So any confusion in this? Okay. In the same way, if we consider one more question, because there are so many questions like this in the theoretical past papers. Okay, this one. Now we have LED. It shows the circuit diagram for a flashlight, that is torch, and the EMF of the battery is 4.5 volt, and it contains a 60 ohm fixed resistor. Current in the LED is 0.02 ampere. Calculate potential difference across the LED. So what will be the potential difference across LED? Remember one thing, both are connected in series combination. So that's why we have EMF and potential difference term in the question. So this will help you to differentiate between EMF and potential difference. This is 4.5. Resistance is 60. And current is 0.02. Okay. We know that in series combination, current remains the same. So the first important idea, current remains the same in series combination. So same current flows through this resistor. So first of all, we have to find out the voltage of this resistor. Out of 4.5, let's see how much this resistor consumes. So V equals to IR. So it will be 60 into 0.02, 1.2. So it means that this resistor takes 1.2 from 4.5, and rest of the voltage will be taken by the LED, right? Because they are in series combination, so voltage will be different. So for LED, 4.5 minus 1.2, 3.3. Because we have series combination. Okay. Explain why the LED does not light up if the battery is reversed. So if you reverse the battery, so what do you think? Why LED does not light up after reversing up the battery? Any idea?
Because the diode only allows the current to flow in one direction. Right?
Correct. Because LED itself says light emitting diode. So diode means it only allows current in one direction, right? It is mentioned LED light emitting diode. So this is basically a form of diode. So you just simply say because diode or LED allows only one direction to flow for charges. The part, the chemical energy stored in the battery is 1050 joules, and show that flashlight operates for approximately 3 hours. So energy is given, and we have to show that flashlight operates for approximately 3 hours.
We can turn 3 hours into minutes or seconds, so
So we know that energy is given, and the formula of power is energy upon time. So if we use the formula, power is equals to voltage into current. Total voltage is 4.5 because they are talking about battery. So the voltage of battery is 4.5 and the current generates 0.02. And the final answer for this will be 1050 divided by bracket 4.5 into 0.02. 11666. But this is in seconds. We have to divide this value by 60 into 60. So it is equals to 3.2 hours, which is approximately 3 hours, right? And D part, calculate the total charge that flows through LED in 3600 seconds. So this is the time, and we have to calculate the total charge. So simple, I is equals to Q over T, or Q is equals to IT. 72 coulombs, right? So this is another question and different form of question as compared to the previous one. In the same way, if we consider one more, okay, these are related to basically potential dividers. So uh, we have to first discuss about potential divider. Then we will solve this potential divider concept. Okay, let's try this one. Question number 8. The unit of two electrical quantities, EMF and potential difference, is the volt. State one other similarity between EMF and potential difference. So one similarity, that both quantities have same unit. So what are the other similarity between them? Anyone? Basically, if you remember, the definition for both, the definitions are almost same. Like one definition says it is the work done per unit charge, and other one says energy converted. So basically, they are making up the same sense. So both EMF and potential difference shows energy conversion per unit charge. Because if you remember, we discussed in EMF, we are using battery, so chemical energy converts into electrical, and in potential difference, electrical energy converts into the other form of energy that is depending upon the component. And one difference between EMF and potential difference. So one difference is very simple. EMF is the voltage of the battery. Potential difference is the voltage across the component. And a battery consists of four cells, each of EMF 1.2 volt in series. Calculate the EMF of the battery. So we know that in series combination, we have to add them. So 1.2 multiplied by 4. So that will give you the EMF of 4.8. And in the second part, we have 1, 2, 3, 4 resistors connected, each resistor of 12 ohms. So calculate the total resistance of this arrangement. So you have to find out the net resistance, equivalent resistance, total resistance, whatever you can say. So we have to find out that value. So basically, when you get this type of question, so remember one thing, we have to solve step by step. Like first we select any two, so we have to solve in pairs. If you try to solve all together, so you will never get right answer. You always get like the wrong answer. So that's why try to solve one by one. So it will be easy for you. So first of all, if we start, so first of all, we have to start with these two resistors that are connected in series. Let's suppose this one equals to R1, this one is R2, this is R3, this is R4. So now, first of all, we have to add R1 and R2. So R1 and R2 are in series combination. So R12 is equals to R1 plus R2 because they are in series combination. So 12 plus 12. Now R1 and 2 are joined together. So they become a combined resistor, right? So now we will consider with R3. So R12 and R3, they both are in parallel combination. So 1 over R123 is equals to R12 R3. Because both are in parallel combination, so we have to solve them first. So it will be 1 divided by 24 plus 12. 0.125. And finally, we have to shuffle the values. It will give you answer 8. And finally, when we combine all of them, so this circuit will be like this. So we have R4 and we combine R123 together. So this is combine R123. So you can see now R123 is in series combination with R4. So we have to apply formula of series combination, that is for R1, 2, 3, 4 all together. So 8 plus 12. So 20 ohms is the total resistance of whole circuit, right? So in this way, you can also practice questions from this worksheet. Next part is related to the potential divider concept. So in next class, when we discuss about the potential divider, so then we will solve the questions related to potential divider because there are also different types of questions available for potential divider. So that's why we are not practicing this part right now. We will practice this part with the potential divider concept. Okay.